What's up YouTube? This is Jacob from International Precision Engineering, and I want to talk about where we are on our positioner project. We finally got an incentive to finish it. We have a demo in 3 weeks to display some of these old confocal sensors, and we've been challenged to use the Intel Edison as the sort of central CPU. So let's go through where we are and where we're going. As you can see here, our CNC 3020, we have our faceplate that we machined, tapped for 1/4 20, and that's just my preference. And it's half inch grid on there. In the last video we talked about swapping the motors out for the 4th and 5th axis to put it in this position, but in this challenge to use the Edison, we're going to use these old confocal sensors mounted on the bridge here to measure a part like a CMM. So it doesn't make any sense if this isn't a tool to measure on a rotary table like this, because this doesn't need, the machine can do a circle and the positioning accuracy doesn't need to be that great. So for this project, I'm actually going to mount it on the table, either maybe something like this or like this, but this gives us 2 cross axes essentially, so we could spin the part in both axes perpendicular to the sensor axis, so we can do 5-axis scanning, and it makes a little bit more sense like that. So in order to mount it up on the table, because we made the rotary bracket hang down past the base here, we need to make just a little bit of a spacer to make that work. In terms of the table here, you could, this came with these aluminum extrusion surface here, which depending on how much time we have, we might just remount. But as you can see, this machine has been stripped of all the anodizing and polished. What I would like to do is take this granite or this marble tile and do a actual marble tile top, and what we'll do is we'll probably obviously cut it to fit, but we'll throw some threaded inserts in here so that you can mount things to it, and I think as a CMM it'll just make it look a lot better. Give you a little bit closer of a view, you could see that we have it sort of polished here. It's kind of hard to see because it's a white background, but essentially the whole machine, we did a once over, we stripped the anodizing and polished. Alright, what I've got here laid out is some of the electronics. We've got a Microsoft Life Cam that we sawed off the front and turned into a C-mount, and I show a better view of that. USB hub to make an extensions for 2 Arduino Unos, both running garble, so it'll be like XYZ and then ABC. We have the 2 of the CNC 3020 controllers. One we're gonna steal from the 3040 and the other that came with this machine. Both interface with parallel, so we need to make an adapter that just goes, from the garble pin out to the whatever that is, 25 pin connector. And one thing that I remember is the ground pins on these are not typical to the parallel port spec, so I just bridged all of the unused pins pretty much to ground, and it made much better results. So what ended up happening was it would intermittently step and not. So essentially it was a floating ground. So that's a must-do mod if you're using Garble with these, just so be careful with that. These are the confocal sensors. This one is an older one, and this one is a model with coax illumination, and I can go into what's inside that in a second. And then this is an old, essentially an old laser controller, and what's inside of this is a USB hub and a Arduino Nano. So we don't need the USB hub. It used to run a Thorlabs scientific cam, but we're not going to use that. And the little MPJA laser, those $2 lasers, a tricolor diode, and at the end of this tape here is a lens. Alright, so we got the lid cracked off this just pretty much Radio Shack box, and actually this was engraved using the 3040, I believe. So in here, like I said, it's just a USB hub to split for the Thorlabs camera. This was a little switch to turn the laser power on and off, and this is the Arduino Nano. So I cut the USB wire, soldered it right to the hub, and soldered the external wire, just cut it off the housing. So one of the things that has to be done is all of this magnet wire is garbage. So it's too brittle for sort of an everyday sensor. So what happens is it intermittently makes connection and not. So what's going to happen is all of this wiring is going to get replaced. Like I said, we don't need the scientific cam, so we'll probably get rid of this box and just use a micro USB right into the hub. And what I'm going to do is essentially, so the laser's 2 wires, the RGB LED is 4, I guess, but they can share a common ground, and our life cam is 4 wires, so typical USB. So what I'm going to do is take a Ethernet cable, cut the ends off, and use a normal 9-pin, sort of like the old school RS-232 connector. And what I'd like to do is feed that through all the tracks in the machine. So the sensor will be here. We'll have the whatever it is, DB9 connector here, and then we'll pull all of the cable back through the track of the machine, so you don't, so it's not just a fluff of wires. So we're going to be using these confocal sensors for our positioner, and the principle behind them is pretty simple. So what it is just a housing that holds a beam splitter. And if you're not familiar with a beam splitter, you can see sort of by this picture what it is light comes through this way, but as it passes this half silvered mirror, and really these are prisms, but just think of it as a half silvered mirror where that line would be. Some of the light's going to go through and some of it's going to reflect. So if it's a 50-50 splitter, which is what this is, half the light's going to go through and half the light is going to reflect and come out the side. So what we've done here is we've threaded the top, what you could think of as the top for a C-mount camera or C-mount thread. So we have an adapter here, and I threaded this with female and I made a male-to-male adapter. So what happens is this just goes in, and then your camera would thread on to that. So there's just a dust cover here, but you pop the dust cover off and that would thread right on, and now you have a camera essentially on here. So we got C-mount on the top. We've got a I don't remember what it is, but just basically a thread to hold really nothing except a tube that holds the laser. So this is just a tube that holds the laser, and it's stainless to take heat if we're really pumping a lot of energy into that, which we won't be in this case. So that threads in. So what you can think of as happening is the laser shooting in, half of it blows out the other side, which we don't care, we have more than enough power, but the other half goes down to a DIN spec objective thread. So this would be, so like here's a garbage objective that I use just pretty much as a dust cover. But in principle, what happens is the laser comes through, reflects down, and comes down through the objective. So this is pretty much, if you don't get it perfectly right, what this is acting like is coaxial illumination. So what's going to happen is you're going to image the point source right onto your camera. So basically that's how it works. So if you're far away from that point, it's going to diverge, and you're going to get basically a spread on your imager. As the focal plane comes through that ideal spot, that light's going to come down right to a point, and then as you keep going, it's going to spread back out. So with that sort of characteristic, we can not only image with this, but we can come in and find vertically where a surface is. And depending on your objective, you could have very, very, very high sensitivities. So that's basically the principle behind these confocal sensors. It's nothing crazy, it's just really basic. And when you're using these webcams, which by the way, this is probably 100 times better than that Thor Labs cam was. And Thor Labs cam I think was $400 or $500, and you needed C++ or their software to use it. This Microsoft LifeCam, you can use an OpenCV, and I think these, even on the high end, are like $60. So the sort of upgraded model, or the little bit more clever, is if you have two beam splitters. So here's sort of a cutaway of what that is, and in here there's two beam splitters. So what you can do with this is the laser can fire in here just like before, hit this beam splitter and drop down through. This would zero objective, and again a C-mount thread for a camera. But if you take this one and put a broad source, but purposely away from that point where you're imaging the point source, this will act as an unfocused coaxial illumination. So it's almost like Kohler illumination, but it's not really. And the ideal spot to focus that is going to be right on the aperture, on your sort of aperture of your objective. So right at this distance from your thread stop is where you want to focus that. So when we had that blue tape with the lens, all that was doing was making that LED focus its light right here, and then that's almost a perfect Kohler illumination system. And where I got the lens is I took the lens out of the laser because you don't need it, and then that's where the tape is holding that. But basically this is machined, so the lens drops in, you can hold it with optical wax or whatever, and then the LED comes in right behind it. So that's pretty much it on these confocal sensors, and then that's the same principle. But what the coax allows you to do is image with your blue and green channels on the CCD or CMOS, whatever you're using, and then measure in red simultaneously, or shut off the laser, put on all three channels, and you have a nice white coax illumination, and basically a microscope system. So now with this one, you can come in, image laterally to measure, and measure with your laser to get your depth measurements. So this is the Intel Edison board, or like this, and this is the breakout board, but this part right here with this little sticker on it, this is actually the Edison. So I think the Edison, I don't know, I think it was $50 or $60, and then this board I don't know, you could buy this whole kit, I think, with a power supply, an SD card, and some other like shields and things for like $100. But they're really pushing to figure out how and what to do with these Edisons. That's sort of Intel's new direction. So we've been challenged to use this, and what's nice is you have USB, full USB capability, and it runs essentially Linux. So you can FTP. This Edison has Bluetooth and Wi-Fi built right into it, so you don't need any sort of shields or anything. The shield that we're going to end up using is this touchscreen LCD, which again goes right onto the Arduino format, pins. So that's what we're going to do, and I'll talk a little bit about the software that I'm going to run and how I'm going to interface with it. But this is a really powerful board. I'm really excited to use it. To use the Edison, it's really pretty simple. Because it runs Linux, it's essentially a web server. So what you can do is configure it to run on your wireless network, and then use something like PuTTY or any sort of TTY terminal or anything to SSH into a secure shell is what that's called. So once you have the connection open, essentially you can use terminal to run scripts, run files, things like that. To actually get files to and from easily, what you could do is use what I used, FileZilla, or any FTP. Essentially what this does is it connects almost in the same way, but now you just kind of drag and drop files or double click in FileZilla and it goes from folder to folder. Right, and then you come back to your PuTTY terminal to run it. Pretty easy. And again, because it's a Linux, you can use something like Python. You can develop all of your code on your PC and then send it over and essentially run it in your Linux. Or if you have a Linux machine, then it's probably a little bit more portable, but you kind of get the point. I'm using Python to run all of the sort of higher level stuff. So you have a main Python script. Essentially it's probably maybe 3 lines, right? Initialize the system, start the process, and when it's done, release it, right? You have your sort of functions, you got your initialize system, release system, and what's not there yet is a start process. And then that's going to call all your modules, so your sort of low level stuff or even intermediate level. So this is a CMM controller, right? So in these functions it should be something like measure at this point, or move here, or process this point cloud, or push it to the web. And then those are kind of your modules. And the way that I like to program is I like to sort of break it down into functional sort of system, subsystem. It's pretty much leveraging object-oriented to the max. So you have your main, which calls, so the main function for this demo is going to be like run demo sort of program, right? And it's going to measure a specific object. It'd be kind of almost like running G-code or something on a machine. Like you already thought about what you were going to do, you already planned it all out, and really all you're doing is hitting a button. That's the main. And to make the code easier to use, so the main is obviously interfacing with a CMM, right? So a coordinate measurement machine, or or anything. If it's a mill, then it's a milling machine. But in there is going to be modules for the sensor and then the actual positioner itself, right? So this would handle the sort of intermediate level stuff like go here or measure at this location, and it would tell me how I'm going to measure. So I'm going to move to a start position, move down, grab a frame, process, move down, grab a frame, process. So all that loop would be sort of in the CMM controller thing. And then like I said, there's a module for the sensor and the positioner. So for example, the next level of abstraction is the controls for this CNC 3020. So this is a CNC 3020 class, and in here is going to be the instructions on specifically how to move. So for example, you have 6 axes, so you're spread across 2 different garbles. You have to sort of go in between, and not only that, you have to have part transformation matrices because there's rotation axes mixed with linear, so it's not just, you know, a G54 work offset. You have to essentially work in command and part coordinates, but then internal into this CNC 3020 thing is exactly what to send to the garble, right? Not how to communicate with the garble, but what position to command it to go to. And then in this CNC 3020 is going to be the import garble thread, right? And then this is specifically how to take those commands and talk to the garble. So you got how to talk to the garble, what to tell the garble, what to do, and then how to do it. That's basically leveraging object-oriented programming, and that again is only one arm of this web of modules. So you have the CMM controller, you have point cloud utilities, plotting utilities, web server stuff, you know, like how are you going to interface with this thing. So I know it's been a while, but I hope that gives you an idea of where we are. We are making progress very slowly, but now that we have the incentive and the demo in 3 weeks, hopefully this can get done and we can move on to other projects. See you next time.